solving geometric problems for vectors, okay? And the questions are, basically, these are all geometric problems for vectors in 3D, okay? So the difference in the problems in this book and the previous book is that in book 1, you were solving geometric problems in 2D, but now you're going to be solving vector problems in 3D. So coordinate A is 2, -5, -8. So we've got A, B, C, D are the points, and I'm going to just write those down. This is on page 344, and it's the first example in the section 12.3. Coordinate B is 1, -7, -3. C is 0, 15, -10, and D is 2, 19, and -20. And the question says find a B vector and DC, and it says give your answer in the form I, J, and K. So AB vector we know is B minus A, so that's just going to be, I always like to do this in column vector form, it's much quicker and much easier. Okay, so I'm gonna have -1, -2, and 5, and that will be in IJK form. It'll be -I -2j plus 5k. Okay, so that's AB, and let's find DC. So DC is C minus D, which is 0, 15, -10, minus and C minus D. Okay, so D is 2, 19, -20, and that gives me -2, -4, and 10, which can also be written as -2i -4j plus 10k. Okay? Then it says show that the lines AB and DC are parallel and that DC is twice AB. So let's write those down again. AB vector, and I'm again going to write it in column form, much easier. AB is this, DC vector is -2, -4, and 10, and which is the same as, if I take 2 out as a common factor, I'll get -1, -2, and 5. So AB is twice, so 2AB is equal to DC. Okay, so twice AB will give you DC, as DC is longer. Then it says hence describe the quadrilateral ABCD. So if I've got AB vector and I've got DC, which is double its length, and they are both parallel, then I can draw something like this. And so basically ABCD is a trapezium, and we know that because it's got AB and DC as parallel. So ABCD is a trapezium, and AB and DC are of unequal lengths. Okay, and it doesn't matter how you draw it. Okay, the next example is on page 344, and it says PQR are these points. Respectively, find the coordinates of the point S. So this point is unknown, so that PQRS forms a parallelogram. Now PQRS, now this diagram was not given in the question, but as long as you draw PQRS either anti-clockwise or in clockwise direction, it doesn't actually make any difference. Okay, just draw any random parallelogram and label the coordinates either in anti-clockwise or clockwise direction, and then go from there. Okay, so it says find the coordinates of S such that PQRS forms a parallelogram. So the first thing we need to do is let's work with the things that we know. So we do know PQ and we do know R. So let's work out the vector QP. So the vector QP is going to be P minus Q, and again I'm going to work in column vector form because I find it much easier and quicker. So this gives me minus 3, minus 2 and 4. Okay, so this vector QP and the vector RS, they are both parallel. Okay, so what that means is that they should be equal to each other. So the vector RS then is S minus R, and we don't know S, so I'm just going to call it XYZ. XYZ minus, and R we do know is 8 minus 2 and 0, and we know that RS is exactly the same as QP vector. Okay, because both the size and the direction are exactly the same, so this is equal to minus 3, minus 2 and 4. So now I've got equations which I can solve. So x minus 8 equals minus 3, x is equal to 5, y plus 2 equals minus 2, so y is equal to minus 4, and z is equal to 4. Okay, so that means that S vector is 5 minus 4, 4. Okay, simple as that. Okay, next part of the video we talk about coplanar vectors. Okay, so basically we are going to be able to compare coefficients if vectors are in the same plane, and we'll be able to find any unknown vectors. Okay, and the explanation is on page 345. We're just gonna straight go on to an example. Okay, this is an extension from book 1 vectors. Okay, you did a very similar exercise in 2D vectors back then. So I would advise you to look back in book 1 to refresh your memory if you've forgotten anything. But basically it says given that 3i plus p plus 2j plus 120k is equal to pi minus qj plus 4pqrk. So k, I, j and k are all vector quantities. I'm just going to underline them to differentiate those between p, q, r. Find the values of p, q and r. So compare coefficients. If this vector is equal to this vector, then obviously the individual components must be the same. So comparing coefficients of I will give p equals 3. Okay, then if I compare coefficients of j, then p plus 2 is equal to minus q. So we are going to get an equation. Okay, we already know p is 3, so we can actually sub that in. So that means q is equal to minus 5. Okay, q is minus 5, p is 3, and now compare coefficients of k. So 4pqr is equal to 120. 4 times 3 times minus 5r is equal to 120, and that gives us r is equal to minus 2. Okay, so that's how you can solve vectors which are equal if they are in the same plane. You can use those, you can compare coefficients to solve for any unknown quantities.